Now guys, we're on page 62 here, but it's sheet 5. This is called tangent planes. And just finding my pencil here. Okay, so in the 3D here, you can see there you've got a 3D cone and a point of contact. But what they're looking for now is a tangent plane. And I'll just throw in a line here now. In this, you see they have a point P on the cone. And they said draw the traces of a plane that is tangent to the cone at point P. But see, that's a small bit, I suppose, misleading really. And that if you put a plane up against a cone, and I'm going to put the plane in here, in maybe blue or something, in the 3D. But if you put a plane in against there, that's going to be the horizontal trace. And I'll just guess the angle of this here now. But in the 3D it'll be kind of parallel to the line of contact here. And I'll just do the same here now. So let's say we put a kind of a rectangular plane in here. That would be the vertical trace. That's our plane there. Think of it as a sheet of glass or something like that. But if you put a pane of glass or a rectangular piece of glass sitting on the ground, it's lying back against the cone. So the red thing there is the line of contact. And you need to be able to understand it in 3D before you'll be able to understand it in 2D. So when I come over here to my 2D, the first thing I'm going to draw in here is the line of contact. And the plane there then needs to go at 90 degrees to that. So I'm just going to set up my set square there and then flip it around to get a 90-degree angle tangent to the base. So I'll put this in blue now as well. So this here is my horizontal trace. And what you do need to know now is a little bit of, and of course, just using basic stuff that we've already looked at there to do with points on cones. If I bring up where the line of contact hits the ground, this is my line of contact in the elevation, and P is on that. But really it's the traces we want. Now to get the horizontal or to get the vertical trace in, which is this line here, what I'm going to do is I am basically going to, on the 3D I'll show you here, I'm bringing the apex of the cone parallel to the horizontal trace. So when I bring the apex of the cone parallel to the horizontal trace, that there is this point. If I call it point X, no, we'll call it point X. So that's point X in plan, and we know in elevation it has to be straight up here and it's at the same height as the apex. So that there is point X. And we know the vertical trace goes through that. So I'll just put that in there now. So that's our vertical trace, horizontal trace, and 3D of it. Now, another way I could have found that vertical trace is I could have used P. If I brought P in parallel to the trace, to the horizontal trace, because by bringing P parallel to the horizontal trace, you don't change the height, and then bring it up. And I could have brought it across from point P here. And you can see there that that gives me the point on the trace also. So what is the key concept? I suppose that the horizontal trace is perpendicular. I'll put the symbol. So the horizontal trace is perpendicular to the line of contact. Because as I say, if you lay a rectangle up against a cone, it doesn't just have a point of contact, there's a whole line of contact. So that's our first one done. Now the second one here says, draw the traces of a plane that is tangential to both the cone and the sphere. Now I wouldn't call it a trick question, but really, if I sketch over here a horizontal plane and a vertical plane, so there's our planes of reference, and what we've got here is a cone and just behind it there you've got a sphere. I'll just move it out a small bit. You've got a sphere like this, and what you've got to do on this is you've got to make another cone that's parallel to this cone. So we're going to build a cone that's parallel to that cone, and then we can put, I'll use blue like the last one, this is the principle of it, then we can lay our rectangular oblique plane, and I'll just put in the lines of contact. So you would have a line of contact along here and a line of contact along there, and the plane is going to look then something like this. So that's the idea behind it, okay? That you make a second cone that is tangent to the sphere, and the second cone has to be parallel to the first one. So let's do that first, okay? So my parallel cone, the apex is going to be up here. So I'll just get the slope of the first cone here. And if you want to be really exact, you could go perpendicular out from here, and that's the point of contact. And there is my tangent cone, and I'll just guess the other side here now because it'll be accurate enough. Right, so there is my parallel cone, and that's enveloping the sphere. Okay, but it has to be parallel. That is the idea behind it, so it has to be the same slope. Now we're going to draw the plan of that next, so I will just take the radius here of the base, and I'm going to draw, now I don't need all of this really, but that's the radius. So that is the base of the cone now that I've drawn over here. And I'm now going to get my blue, because I've been using blue for the plane, for the oblique plane. So it's going to be touching the base of both cones. So that there is my horizontal trace. And if you wanted now, and I will, I'm going to put in the line of contact here. So it's going to be perpendicular to the trace. Now I wasn't asked for this, but I'm going to put it in because it will help you to understand it. So that's the line of contact there. That's the line of contact with this one. So those red lines, or these red lines, that blue line here is the horizontal trace. And now our next move then is we want to find the vertical trace. So I'm going to just bring in the apex of one of the cones. Doesn't matter which one, I'll work with the top one, with the bigger one. So I'm going to bring that apex in parallel to the horizontal trace into where it hits the XY line. Just put an arrow on that there. So I brought that in. So this is the height. This is at the height of the apex. So at the height of the apex, which is, oops, here. So that's the same as I did in the previous question over here. Okay, so where I ran in the point of the cone, the apex, brought it up and brought the height across. I'm doing that again. So I brought it in parallel to the trace, brought it up, bring the height across, and that's a point on the plane. If I just turn this over here for a second. So that is like what I did here. That is a point on the vertical trace, and because you only need 1 point, and that here is my vertical trace, horizontal trace. So draw the traces of a plane that's tangent to both. So anytime you see that, you need parallel cones if it's a cone and a sphere. Now I could very easily then, if I wanted, find the point of contact as well. I suppose I don't really need to, but the point of contact could be found, and it's going to be on the red line here, but and it would be at this height. So because this is going to be the height where the cone, so that would be the height, but I wasn't asked for it, so I'm going to leave that out there now because I don't want to just over confuse people. I'm sure we'll get to it in the later questions. Now question 3 here, given the projections of a hemisphere, determine the projections of a plane that is tangential to the hemisphere at the given point. Okay, so I'm going to do a few things really. I'm going to find that point in plan. So first of all, if you take a horizontal section through P, take that down to plan, it's going to be straight below here, and the horizontal section is going to give me a radius out to the circle here, so out to the outside of the hemisphere. So that's going to be my radius. Now you could draw in the whole circle there for that horizontal section, but it won't tell me anything more than that P is here. Now, if I moved, so look, if I move P out to the outside of the circle, to here, what I'm going to end up doing here is I'm going to end up making an upside down and inverted cone. So that is the angle. That is the angle of the, that is the perpendicular to the tangent. So what I'm going to do here now is I'm going to just go 90 degrees to that. So this would be an inverted cone. Now, does it matter what height I make this cone? It doesn't really. So like, I'm going to make it a small bit higher, I think, just because I don't want to confuse people with the top of the hemisphere here as well. So this upside down cone, so I'll just measure there how far the base is here. So it would be going the same distance over here. So that there would be my upside down cone, or an inverted cone, and that is a tangent to the hemisphere at, if I use yellow here, I'm going to put in here what I would call this is actually a circle in reality. I know it looks like a line, but that yellow thing there is the circle of contact. Because if you put a ball into a hollow cone, it gives you a circle of contact. Now I know it looks like a line in the front view, but and I will heavy this in actually, it might help people to understand. So I'll just finish off this circle of contact here. Okay, and I'll just colour this in yellow there to help people. So that there, I don't need to probably do all of it, I'll just do a little piece of it. So the yellow one there is our circle of contact. And it looks like a line here in the front view. Now really what I've got here now is a truncated cone. So, whoa. So if I just try doing a sketch out here now, even though my traces, this is probably going to be in the way, but whatever, we'll get over it. If I had a horizontal plane, a vertical plane, and what I've got here is a truncated cone, and I've got a point on that truncated cone like this. And because you can kind of forget about the hemisphere now is inside in this truncated cone, and we want to deal with the cone there really, so forget about the fact that the hemisphere is inside in it. Our plane now is going, this is going to be our line of contact, and the oblique plane will be running along tangent to that. And what's complicated about this now is it's actually going to be leaning out the ways. Unfortunately there now, I'm going to move and extend this now in the hope of helping people. I'm just going to extend out my horizontal plane here. Okay, so there's my horizontal trace, but that's because that's leaning out the way, it's kind of going to actually look like this. So that's our vertical trace and horizontal trace here, and that would be our oblique plane. So it's leaning out the way. That is the problem. So what I'm going to draw next is I want the base circle of this. You can see there, you want the base circle of that cone. So the base circle, we're going to take it from the elevation here. That is the base circle of that. Because that is going to give us, now, do I need the whole circle? No, I don't. I'll just draw it in there in the hope again there that it might help people understand it. So, and I'm going to also there just join P back to the center here now. Okay, and if I had a line of contact now, that's going to be my line of contact there. That's the angle of the line of contact. And we know that the trace is going to be going 90 degrees to that, like we saw in the first two questions. So the trace is going to be going 90 to that. So there's my angle for the line of contact. So the trace, and remember now, the trace now is touching the base circle on the ground, which is this circle here. So this here is my horizontal trace. Now I'm just going to put this dotted because it's going in underneath. So that's my horizontal trace. And our problem here now is how do we find our next problem, I guess. So again there, just note that the horizontal trace is a tangent to the base circle here, which is this circle. So it's a tangent to that, perpendicular to that line. Now we need to find next, so I'm going to use point P this time. Now is there other ways I could find it? There is, but I'm going to use the height of P because I only want 1 point. So I'm going to run P in here parallel to the trace. So here is the height of P. Just put an arrow on that. Then bring that up vertical. And bring the height of P out. And that there is a point. So what I was doing there on the 3D is I was bringing the height of P in to the vertical plane. And once I have that, then I know I can draw out through there. So I'll just get my blue for this. And this is my vertical trace here. So I know that looks very straight there now, but it's because this is leaning out the way. It's a bit unusual. So that there is our vertical trace. Now if I didn't know P, you might say, how the hell would you do it? And what I would do is you could draw the top circle here, the base, the big base of the upside down truncated cone. I could have drawn the big base and I could have used the top of the line of contact on that. It would be out here somewhere. Again there now, I know I've already answered the question, but we're trying to learn from it. So out here would be the top of the line of contact. So that there would be the full line of contact, and I could bring that up to the elevation. So that there is the top of the line of contact, and we know it's going through P. and we know it's here on the ground as well. So I'll just, I could extend through P, but I'll just bring it up here. That's it on the ground. This is the line of contact going through P. And if I wanted, I could have brought that point in there now, which is the top of the line of contact. I'll just prove it to myself, I suppose. No, I'll prove it to you. I believe myself. Okay, so if I brought that in parallel to the trace, bring it up, and take the height across from here, you will find, okay, that it's actually out here. And the thing is, the closer you take, now they're both, like that point is correct and that point is correct, but it's just when you're drawing a line based on 2 points that are very close, you can see, like if I had the set square angled like that, my trace would still be going through that point. Like we're only talking, you know, if you're 1 millimeter out here, so like that method is perfectly right. So I just put some arrows on that. So like that would have been another way of finding a point on that vertical trace there. So as I said, don't worry about the inaccuracy of it. Nice question, bit tricky for sure. Now again, the last one here now, whenever there, what we've got here is, if I sketch a vertical plane of reference and a horizontal plane of reference, is we've got a cone over here and a random point that's up in the air. But again, this goes back to the question just above it there. Parallel cones, that's what they're looking for. They want, or the way to do this, okay, is make a parallel cone where this point P is the apex, and we've got parallel cones then, which makes the solving of it really simple. It's the same as the one question 2 we did just above. So parallel cones is where we're going here. So here is my angle. So just make sure you're pretty accurate for this side angle here. There's our angle. Parallel. And again, I could go parallel to the other side here, even though I don't particularly like doing both parallels, because, okay, but there's my parallel cone there, so that's parallel to that, this generator's parallel to this, and I'm just going to bring down the axis, because the radius of the base of that cone is, I can take it from here, so that there is the base radius. And now what I've got here now is the 2 cones, and what I'm going to be doing next there then is putting on our now if I was doing this in 3D again, I'll have to extend. I should have kept the cone in a bit closer there to the thing. I'm just going to extend the vertical plane and the horizontal plane, because they're infinite. So seeing as I'm using blue for my traces, this is the horizontal trace tangent to the 2 bases, and then we're going to be bringing in the height of one of the apexes, and that's going to be giving me a point on the vertical plane, and that's what my oblique plane is going to look like, something like this. Now obviously, or maybe it's not obvious, maybe nothing is obvious in graphics, depending on how good you understand it, I guess. But here's my lines of contact. But like obviously I'm making nice sort of quadrilateral oblique planes. They go on forever. Like, I mean, that horizontal trace goes on forever, and that vertical trace goes on forever. So I don't know if it helps or not to be enclosing it, because they are infinite. But I'm just trying to help people by picturing laying a rectangular thing up against two cones. So now, tangent to the traces, sorry, the traces tangent to the bases. Alright, so here is my horizontal trace. And I want to bring an apex. So again, I always go with the taller one, because it gives you a more accurate, the further away, the more accurate it is, the 2 points in a line. So that is parallel to the trace. So I'm going to go straight up from there. So I brought that in parallel to the trace in plan, so straight up then and across from the elevation. Here is my point, that point there. So my vertical trace goes through that vertical trace and horizontal trace. And again, I wasn't asked for them. I will put them in again there. If that is the angle of the trace, the line of contact is perpendicular to that. So that would be there and here. And in elevation there then, that's where it hits the ground. That's where the small one hits the ground. So that's my line of contact here, and that's my line of contact there. And you know, if you don't, you'll never understand it if you can't picture these things in 3D and picture that line of contact and the plane. Now we only show the horizontal trace and the vertical trace of where the plane goes through the vertical plane and the horizontal plane. Okay, so we don't ever show, like, you know, because that goes on infinitely, we don't ever attempt to show anything other than where it goes through the vertical plane and where it cuts through the horizontal plane. So yeah, very, very important sheet to understand, this one. Great sheet.